Let's talk about anonymous function, also called lambda. And anonymous function is a function without a name. And we often use it in cases where we want to have some simple function for one-time use only. So if there's a function I only want to use once, then maybe it would be overkill to think about the name, and also the code for this function would take a lot of space in our program. And how do you define a lambda or anonymous function? So basically we will write lambda, and we will have arguments here, let's say a and b, and then we have return expression. So basically I can say a plus b. And as you can see, we don't write return here. We don't add parentheses here. This is basically the same as I would write define. Now I have to think up a name, let's say function called f. A and b are the parameters, and I will return a plus b. So basically those two are the same. The difference is that here I have to think up the name, and I also have to write the return, and I have to write define. Okay, here instead of define I will use lambda, but in some cases you only want to use this function once, and then there is no point to think about what can be the name and so on. Of course, we usually would like to have the functions meaningful names. So instead of f and f1 and f2 and so on, we would probably want to write define calculate area of triangle or something like that. And what we can do, we can put this lambda into a variable. I can say that this is, let's say, dA. dA is the triangle area. Okay, so instead of a and b, I could probably multiply those and divide by 2. So let's say this is the height of this triangle. And now what happens is I've defined a function which is put into dA. In this example, it might already make sense to kind of define a function called dA and have it written like that. Return a times b divided by 2. Often we use lambdas inside another functions or another places where we don't have to put those into a variable at all. So we even don't want to use them later on. We just need a function to do something, but we don't need to use them later on. And in this case, we don't put the lambdas into variables. But this is just an example that I can write this all together is a function, and I can put a function into a variable. And now what happens is that later on I can use dA and pass in some variables. Those variables or those values are put into the parameters here, and this value is returned. Here is an example. This example shows how we can use functions inside functions. So basically we have first we define a function which is make incrementer, and it takes in a parameter n. This is normal definition of a function, although it's on one line. The return could be on the separate line. Maybe it would make more sense. But what it does, it returns a function. So the make incrementer, if I pass here 5, what happens is that it returns a function, and the function accepts a value x, and it returns x plus n. the n is the one which I created when I called out this make incrementer. So basically what I do is I call out make incrementer with value 10. Now what happens is that it actually returns us something like that. So it returns us a function, lambda function, where we have one parameter, and it returns value where I add 10. That's the idea of incrementer 10. And then I will have incrementer 5. So basically I will have a function which increments the value x by 5. And now I can use those two functions, which one increments by 10 and one increments by 5. And then I can pass in 10, and now the 10 becomes 20. And now if I pass 10 here, the 10 becomes 15. So this is also not very common way to use functions or lambdas, but this is to show that you can use functions inside functions, you can return functions, you can return functions which you can put into variables, and later on you can use those variables as functions to call out those functions you returned from the make incrementer function. So yeah, this is not very common, and you often don't write code like this, but this is what is possible with lambdas and functions.